Welcome to physics class, children. Today we are going to see with atom models. So these atom models you have seen studied already in your lower classes. Okay, so just like that we are going to see it once again. First we are going to see with J.J. Thomson model, and this is also called as a watermelon model. In this model, atoms are visualized as homogeneous spheres which contains uniform distribution of positively charged particles. Okay, so atom is a sphere and it has a uniform distribution of the positively charged particle. Okay, so that is the model. Then the negatively charged particle known as the electrons are embedded in it like the seeds in the watermelon. So இது ஃபுல்லாகவே ஒரு பாசிட்டிவ் சார்ஜ் ஆகும். ஓகே, அதில் நெகட்டிவ் சார்ஜஸ் வந்து அங்கே இங்கே ஒரு வாட்டர்மெலானில் சீட்ஸ் இருக்கிற மாதிரி டிஸ்ட்ரிபியூட்டாக இருக்கிறதாவும் சொல்லியிருக்காங்க. தட் இஸ் ஜே.ஜே. தாம்சன் மாடல். தென் atoms are electrically neutral. That implies that total positive charge in an atom is equal to the total negative charge. So atom வந்து நியூட்ரலாக இருக்கிறதுனால இதில் இருக்க பாசிட்டிவ் சார்ஜும் ப்ளஸ் இதில் இருக்க நெகட்டிவ் சார்ஜும் எப்படி இருக்குது, ஈக்குவலாக இருக்குது அப்படின்னு சொல்லியிருக்காங்க. அக்கார்டிங் டு திஸ் மாடல் ஆல் தி சார்ஜஸ் ஆர் அசியூம் டு பி அட் ரெஸ்ட். இந்த மாடல் படி எப்படின்னா எல்லா சார்ஜுமே எப்படி இருக்குது, ரெஸ்ட்டில் தான் இருக்குது. பட் from classical thermodynamics, no stable equilibrium points exist in electrostatic configuration. So electrostatic configurationல எதுவுமே வந்து ஸ்டேபிளாக இருக்காது அப்படின்னு சொல்லியிருக்காங்க. Hence such an atom cannot be stable. So ஒரு ஆட்டம் வந்து என்னவா இருக்காது, ஸ்டேபிளாக இருக்காது. Further, it fails to explain the origin of spectral lines observed in the spectrum of hydrogen atom. So hydrogen atomல spectrum அப்படின்ற ஒரு கான்செப்ட் சொல்லியிருப்பாங்க. அதை வந்து இந்த மாடலில் வந்து எக்ஸ்பிளைன் பண்ணலை. Okay, so this is about J.J. Thomson model. Next we are going to see is about the Rutherford's model. So according to this Rutherford's model, it is based on the advice of teacher Rutherford, which is known as the scattering of alpha particles by gold foil. Okay, so you are going to consider gold foil, and in that gold foil what is being scattered is alpha particles are being scattered. Okay, a source of alpha particle which is a radioactive material, and we are considering it as polonium. Okay, is kept inside a thick lead box with a fine hole. Okay, so this is a thick lead box, and this thick lead box has a fine hole here. That the alpha particles coming through the fine hole of the lead box passes through another fine hole made on the lead screen. So இந்த fine hole இருந்து வந்து என்னவாகுது, இன்னொரு fine hole வருது. அது என்னது, that is a lead screen. Okay, then these particles are now allowed to fall on a thin gold foil. So ஒரு thin gold foilல இந்த particle வந்து strike ஆகுது. Okay, and it is observed that alpha particles passing through the gold foil are scattered through different angles. So இதில் என்னெல்லாம் alpha particles இருக்கோ அதெல்லாமே different angle என்ன ஆகும், scatter ஆகும் அப்படின்னு சொல்லியிருக்காங்க. Okay, and that is being made to pass through the fluorescent screen, and it is viewed with the help of a microscope. Okay, so a movable screen which is made up of zinc sulfide, and it is kept on the other side of the gold foil to collect the alpha particles, and whenever the alpha particle strikes the screen a flash of light is observed. அதை எதை வச்சு பார்க்குறாங்க, through a microscope. Yes, and Rutherford proposed atom model based on the results of alpha particle scattering. So alpha particle scattering வச்சு Rutherford இந்த model propose பண்ணியிருக்காங்க. According to this model என்ன அப்படின்னு பார்த்தீங்கன்னா, alpha particles are allowed to fall on the atoms of metallic gold foil. Then he expected the nuclear model to be as this. Okay, so இதை மாதிரி இருக்கணும் அப்படின்னு நினச்சி பண்ணார் அந்த எக்ஸ்பெரிமெண்ட்டை. ஆனால் அப்சர்வேஷனில் என்ன கிடைச்சது, இந்த மாதிரி தான் கிடைச்சது. ஓகே, ஸோ அதை வச்சு என்ன பேஸ் பண்ணி சொல்கிறாரு அப்படின்னு பார்த்தீங்கன்னா, மோஸ்ட் ஆஃப் தி ஆல்ஃபா பார்ட்டிகல்ஸ் ஆர் அன்டிஃப்ளெக்டட் த்ரூ த கோல்ட் ஃபாயில் அண்ட் வென் ஸ்ட்ரெயிட். ஸோ மோஸ்ட் ஆஃப் த ஆல்ஃபா பார்ட்டிகல்ஸ் என்ன ஆச்சு, நம்மளுக்கு வந்து ஸ்ட்ரெயிட்டாக போயிடுச்சா. ஓகே, ஸோ மோஸ்ட் ஆஃப் த ஆல்ஃபா பார்ட்டிகல் வென் ஸ்ட்ரெயிட். நெக்ஸ்ட் some of the alpha particles are deflected through some angle. So some angle-ன்றது so இதுதான். Okay, so some of the alpha particles are deflected through some angle. Then a very few alpha particles are deflected to an angle of 90 degree. Okay, so very few alpha particles are deflected more than 90 degrees. So more than 90 degrees it is being deflected back along the other side. Okay, and very few are written back, that is deflected back 180 degrees. So 180 degree is the same way. Okay, so in what path it is traveling, the same path it is returning back. Okay, that is for very few particles. Okay, so these were the observations made by Rutherford. Yes, I'll say with the observation once again. Okay, very few are deflected, most of the alpha particles are undeflected. So நிறைய particle என்ன இருக்கு undeflected போயிட்டு இருக்கு. Very few alpha particles are deflected through some angle and very few for 90 degree and very few are along 180 degree. Okay, then the dotted points are the alpha particles scattering experiment, and it is done by Geiger, Madsen, and the solid curve is a prediction from Rutherford's model. Okay, so these are the dotted points. Okay, so that dotted point says with the Geiger and Madsen, and in the curve இருக்கு இல்லையா, so in the curve வந்து என்னது Rutherford. So more or less எப்படி இருக்கு, ரெண்டுமே சேம் தான், because this dots and this line is more or less same, so it is in being agreement with the experimental data. Yes, clear with this? Next, conclusion of Rutherford based on the observation is Rutherford proposed that the atom has lot of empty space, because இந்த மாதிரி நம்மளுக்கு வந்து போகுது அப்படின்னா என்ன ஆகும், இந்த இடத்துல எம்டி ஸ்பேஸ் இருக்கும், எம்டி ஸ்பேஸ் இருக்கு. அப்போ contains a tiny matter known as a nucleus whose size is of order of 10 power minus 14. ஸோ அந்த இடத்துல என்ன இருக்கு, ஒரு நியூக்ளியஸ் இருக்கு, அதோட சைஸ் என்ன இருக்கு 10 power minus 14 இருக்குன்னு சொல்லியிருக்காங்க. நெக்ஸ்ட், நியூக்ளியஸ் வந்து ஒரு பாசிட்டிவ்லி சார்ஜா இருக்கு. மோஸ்ட் ஆஃப் தி மாஸ் இஸ் கான்சென்ட்ரேட்டட் இன் த நியூக்ளியஸ். எல்லா மாஸுமே என்ன இருக்கு, நியூக்ளியஸ் தான் கான்சென்ட்ரேட்டா இருக்கு. It is surrounded by the negative charge. So இது சுத்தி கொஞ்சம் கொஞ்சம் என்ன இருக்கு, negative charge இருக்கு. Since the static distribution cannot be in stable equilibrium. So இந்த equilibrium வந்து ஸ்டேபிளா இருக்காதுன்றதுனால the electrons are not at rest. இது வந்து electrons வந்து ரெஸ்ட்ல இருக்கு, மூவிங்லே இருக்கு அப்படின்ற மாதிரி. How the planets are revolving around the sun, அதே மாதிரியே எலக்ட்ரான்ஸும் அந்த நியூக்ளியஸை சுத்தி மூவ் ஆயிட்டு இருக்கு அப்படின்னு சொல்லிட்டு சொல்லியிருக்காங்க. ஓகே, next we are going to see is the distance of closest approach based on Rutherford model. Okay, for this, when an alpha particle moves straight towards the nucleus, reaches a point where it comes to rest and return back. So alpha particle என்ன ஆகுது, ஸ்ட்ரெயிட்டா போயிடுது, நியூக்ளியஸ் வரையும் போயிடுச்சு, போயிட்டு இங்கே ஸ்டாப் ஆகிட்டு என்ன ஆயிடுச்சு, மறுபடியும் இதே சைடு ரிட்டர்ன் ஆயிடுச்சு. ஓகே, the minimum distance from the center of the nucleus and the alpha particle before it gets reflected, that is said to be the distance of closest approach. Okay, ஸோ இதான் நியூக்ளியஸ் அப்படின்னா, இந்த நியூக்ளியஸோட சென்டருக்கும் இந்த ரே எங்கே வந்துட்டு எங்கேருந்து டிஃப்ளெக்ட் ஆகுதோ அந்த பாயிண்ட்டுக்கும். ஓகே, ஸோ இதில் இருந்து இந்த சென்டர், ஸோ இதோட டிஸ்டன்ஸ் தான் என்னதுன்னா டிஸ்டன்ஸ் ஆஃப் க்ளோசஸ்ட் அப்ரோச். ஓகே, அண்ட் அட் திஸ் பாயிண்ட் kinetic energy is equal to the electrostatic potential energy. Okay, so kinetic energy formula is half mv square. Then electrostatic potential energy we have studied already in the first lesson itself, 1 by 4 pi epsilon naught q1 q2 divided by r. Okay, so now instead of q1 and q2 we are writing as 2e into zt. Okay, q1 is 2e, q2 is zt. Okay, now here e into e, that becomes as e square. Okay, e into e, that becomes as e square. Then bring this r naught this side, and this term we are bringing down, so r naught is equal to this. Okay, and again this 2 we can bring it to the numerator. Okay, so that it becomes as 4. Okay, so sorry, this again half mv square, that is a kinetic energy, is not, so that can be written as ek. Okay, so this term, other terms as it is, this alone we are writing as ek, and this gives the size of the nucleus and the size of the distance approach, and it value ranges from 10 power minus 14 to 10 power minus 15. Okay, so this is determination of distance of closest approach. Next is impact parameter. So an impact parameter is defined as a perpendicular distance between the center of the gold nucleus and the direction of velocity vector of alpha particle when it is at large distance. Okay, so in the gold foil oda centrum, how it makes the angle. Okay, so அதுக்கும் நடுவுல இருக்கிறது என்னது, impact parameter. So this impact parameter is defined as the perpendicular distance from the center of the gold nucleus, and so if this is a gold nucleus, so this is the center of the gold nucleus, and the direction of velocity vector of alpha particle when it is at large distance. So large distanceல இருக்கும்போது எந்த directionல போகுதோ so அதுக்கான perpendicular distance என்னவோ அதுதான் என்னது impact parameter. Okay, so relation between impact parameter and this scattering angle is given by b, that is proportional to cot into theta by 2. Yes, now to remove this proportionality we'll be introducing a constant which is k, and instead of this k we are substituting here is 1 by 4 pi epsilon naught 2 z e square divided by m v naught square, and theta is said to be the angle. That angle is what? The scattering angle. So we can say that B, okay, that is the impact parameter increases, then the scattering angle decreases. Okay, so when the impact parameter increases, the angle decreases. Okay, so this is the impact parameter. Last we have the drawbacks of Rutherford model. Rutherford model helps in the calculation of the diameter of the nucleus and also the size of the atom, but it has following limitations. So size of the atom, what is the diameter of the nucleus, all that has been found out, but there are also certain limitations. This model failed to explain the distribution of electrons around the nucleus. So electrons nucleus சுத்தி electrons வந்து எப்படி distribute ஆயிருக்கு அப்படின்றத சொல்லல. என்ன சொல்லியிருக்காங்க அப்படின்னா it just moves in a spiral path அப்படின்றத மட்டும் தான் சொல்லியிருக்காங்க. So according to classical thermodynamics, any accelerated charge which emits the electromagnetic radiation. So ஏதாவது ஒரு accelerated charge என்ன ஆகுது, ஒரு electromagnetic radiation கொடுக்குது அப்படின்னா then due to the emission of radiation it loses energy. So இந்த மாதிரி ஒரு radiation கொடுக்க கொடுக்க என்ன ஆகும், அது வந்து energy loss ஆகும். So அப்படி energy loss ஆச்சுன்னா என்ன ஆகும், அது வந்து slow down ஆகும். Okay, and it comes to the center. Okay, and no longer sustained with a circular motion. The radius of the orbit therefore becomes smaller and smaller. Finally, it falls into the nucleus. Okay, and it should disintegrate. But this does not happen, and so it is a failure. Okay. Then second one is, according to this model, the emission of radiation must be continuous and must give continuous emission. So இது வந்து என்னது continuous emission தான் கொடுக்கணும் அப்படின்னு சொல்லியிருக்காங்க. But there is also line spectrum which is possible. Okay, line emission is also possible. இதுல continuous emission மட்டும்தான் வரும் அப்படின்னு சொல்லியிருக்காங்க. Okay, so these are the drawbacks of Rutherford's atom model. Next we have the Bohr atom model. So in order to overcome the limitations of Rutherford atom model in giving the stability and also the line spectrum, and Bohr gave the explanation about the hydrogen atom. Okay, and he is the first person to give the theoretical model and the structure of the atom to explain the spectrum of hydrogen atom. So spectrum hydrogen atom இப்படி தான் இருக்கும் அப்படின்றத போர் தான் சொன்னாரு. According to this Bohr, we have following postulates. What are they? The electrons in the atom revolve around the nucleus in the circular orbit under the influence of Coulomb electrostatic force of attraction. So ஒரு நியூக்ளியஸை சுற்றி என்ன ஆகுது, எலக்ட்ரான் வந்து ஸ்பைரல் பாத்தில் போகுது. அதுவும் எதனால் போகுது அப்படின்னா because of what? Coulomb's electrostatic force of attraction. This Coulomb force gives necessary centripetal force. இந்த Coulomb forceனால தான் என்ன ஆகுது, நம்மளுக்கு centripetal force கிடைக்குது அப்படின்னு சொல்லியிருக்காங்க. Okay, then the electrons in the atom revolve around the nucleus only in certain orbits. So ஒரு சில orbitsல மட்டும்தான் என்ன ஆகும், அந்த எலக்ட்ரான் வந்து ரிவால்வ் ஆகும். அந்த ஆர்பிட்க்கு பேர் என்ன சொல்றாங்கன்னா stationary orbits, where it does not radiate the electromagnetic energy. அந்த இடத்துல electromagnetic energy அது வந்து radiate பண்ணாது. Okay, only those orbits are called as a stable orbits. அந்த orbitsக்கு பேர் தான் என்னது, stable orbits. Okay, then angular momentum is quantized. Okay, and it can be written as the integral multiple of h by 2 pi. So angular momentum is written as the integral multiple of h by 2 pi. Okay, so instead of this h by 2 pi it is written here as h bar. Okay, this condition is called as the angular momentum quantization condition. According to quantum mechanics, particles like the electron have dual nature. So electron மாதிரி particles என்ன இருக்கு, dual nature இருக்கு. The standing wave pattern of the de Broglie wave associated with the orbiting electron is shown. So this is a electron which is moving, and from one to the next point the value is considered to be lambda. Okay, this is considered to be the radius from the center to this point, radius r. Okay, so when you consider the number to be 3, we have 6 form of standing wave pattern. Okay, then when you consider the n to be 5, we have 10 forms of standing wave pattern. Okay, so double the form we have. Okay, and it is given by 2 pi r is equal to n lambda. Yes, and we know from de Broglie hypothesis, lambda is equal to h by mv, is it not? So this value of lambda, we are going to substitute it here. So we get 2 pi r is equal to n into h by mv. Okay. Now bring this mv this side and 2 pi down. Okay. So we get mvr is equal to nh by 2 pi n into h by 2 pi. Okay, and we already know that the angular momentum is equal to mvr. Okay, angular momentum is equal to mvr. So this mvr is equal to this angular momentum L, which is equal to, instead of h by 2 pi we'll be writing as what, h bar, is it not? So mvr is equal to L, which is equal to n into h bar. Okay, so have this equation as it is. Next is the energy of the orbits are not continuous but discrete. இதுல வந்து energy வந்து discrete னு சொல்லிருக்காங்க. This is called as a quantization energy. Okay, so when the electron jumps from any one of the orbit to the other one, this difference of energy is given as one form of energy outside. Okay, so that is given by del E, which is equal to E of final minus E of initial. Okay, and this difference is equal to what, h nu, because E is equal to in a formula h nu, is not? So h into nu is equal to, the formula is what, c divided by lambda. Okay, so nu is equal to c divided by lambda. Yes, and so here c is the speed, lambda is the wavelength, and nu is the frequency. So we can say that the frequency is related only to the change in the atom's energy, and it does not depends on the frequency of the electron. So frequency of radiation அப்படின்றது electron frequency வச்சு இல்ல அப்படின்னு சொல்லிருக்காங்க. Okay, so this is h nu. So it is moving through various energy levels and we are getting the same energy. Okay, next is the radius of the electron and the velocity of the electron. So we are going to find the equation for r as well as v. So considering an atom which contains the nucleus at rest and the electrons are revolving around in the radius of Rn. So it has a radius Rn, and since the proton is positively charged and neutron is neutral, nucleus எப்படி இருக்கு, it is a total charge of protons மட்டும்தான். So Z is the atomic number, and so we have Ze to be the charge of the nucleus minus E is the charge of the electron. So from Coulomb's law, so what is Coulomb's law is F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square, is not? Now instead of Q1 we are writing as Ze, and instead of Q2 we are writing as minus E. Okay, so we get the equation as 1 by 4 pi epsilon naught Ze into minus E divided by R square. Okay, so we are writing here as Rn square. This is r cap. Why we are writing r cap is because this is in vector. Okay, now minus plus into minus, so we are writing as minus here. 1 by 4 pi epsilon naught as it is z E into E is E square divided by Rn square into r cap. So this gives you a Coulomb force. Yes. Next, when you write the equation for centripetal force is given by what? F is equal to m v square divided by r. Okay, so F of centripetal, which is equal to m v n square divided by rn into r cap, because we are writing this F in the vector form, so it is r cap. Okay, so we have got both the values of F. Yes, so this is also F and this is also F, so you can equate the both. So we get 1 by 4 pi epsilon naught into Z E square divided by Rn square into R cap, which is equal to m into Vn square divided by Rn into R cap. Okay, so now we need only the value of Rn. Okay, so this Rn alone we are going to bring it to other side. Yes, this Rn will have it here itself. Other terms all we are going to bring it to the next side. Okay, so we'll be getting the value as minus 1 by 4 pi epsilon naught as it is. Okay, Z E square as it is. This r cap and r cap get cancelled. So mv square we have to bring it down. Okay, so divided by m into Vn square, which is equal to what? Rn square divided by Rn, okay. So now one value of Rn get cancelled, so we get Rn is equal to this value, okay. So both the force, if you equate, yes, and getting the value of Rn alone, okay, so this value we are bringing this side, okay, so we get Rn is equal to this term, okay. And in this already we know mv is equal to L is equal to nh, it's not, and so we are writing this to be equal to mvr, we are writing as nh square, okay. And so 4 pi epsilon naught, if you square this we get n square h square divided by z m into e square, okay. And in this h bar can be written as what? H divided by 2 pi, is not, and so we get it as 4 pi epsilon naught n square as it is. Instead of h bar square we write as h divided by 2 pi the whole square, and so h square divided by 4 pi square, okay. Then the remaining terms are z m into e square, yes. Now 4 get cancelled, one value of pi get cancelled, okay. And so the remaining terms epsilon naught h square n square divided by pi m e square z, okay. In this all this term are considered to be constant, epsilon naught h, all this are considered to be constant values, so instead of all this we are writing as a naught, okay. And so we get Rn is equal to a naught into n square divided by z, where a naught is equal to this term, okay. And this all terms are constant, so when you substitute the value we get it as 0.529. This is called as a Bohr's radius, and it is the smallest of all the atoms, okay. So 1 Bohr is equal to 0.53 angstrom, and so this, when you consider the value of z to be equal to 1, z வந்து 1 னு வச்சிட்டோம்னா we get Rn which is equal to a naught into n square, okay. Rn is equal to a naught into n square. Now substitute the value of n to be equal to 1, 2, 3, etc. First, when r is equal, sorry, n is equal to 1, okay. So n க்கு பதிலா என்ன எழுதுறோம்? 1 னு எழுதுறோம். So r1 which is equal to a naught into 1 square, okay. So what is the value of a naught is 0.529. So it is just 0.529, okay, which is r1. Next is for n2. Same way r2 which is equal to a naught into 2 square. 2 square is what? 4. So this value into 4. Same way, next when n is equal to 3, this r a naught into 3 square, so which is 9, and so we get this value, okay. So Rn is also proportional to n. Again, taking with the equation, mvr is equal to what? nh divided by 2 pi, yes. So m vn rn, and we know what is the value of Rn, that is equal to a naught into n square, okay. So a naught into n square which is equal to n into h divided by 2 pi, okay. So these are the different values of the radius when you are considering r1, r2, r3 and r4, etc., okay. And when you write the value of this Vn, okay, from the before equation we get all these are constant, and z is equal to 1. If you substitute we get Vn is inversely proportional to n, and so as this increases, number of the orbit decreases, okay. And we are going to find with the energy. So first we are going to find with what is the potential energy. Potential energy, the formula is 1 by 4 pi epsilon naught q1 q2 by r. So q1 is at E into minus E divided by Rn. Plus into minus is minus 1 by 4 pi epsilon naught is at E square divided by Rn, okay. Now instead of Rn we know this equation, so substituting in this, so we get this to be the potential energy. Next is kinetic energy. The formula is half m v square, and already we know the value of Vn, just now we saw, is not. So substituting this value of this here, and when you compare this and this, okay, this is 1 by 4 epsilon naught square and this is 1 by 8 epsilon naught square. So we can write this as potential energy is equal to minus 2 times of kinetic energy. Okay, now we have to find the total energy, which is kinetic energy plus the potential energy. Okay, so kinetic energy as it is, potential energy is what? Minus 2 into ke. Okay, so this is 1 minus 2, 1 minus 2 is what? Minus 1, so minus ke. Okay, so minus of this value gives your kinetic energy, sorry, the total energy. Now substituting the value of z is equal to 1, then we get this to be the total energy of the particle based on the Bohr's atom model. Yes, clear with this atom model, children? Okay, thank you.